Welcome to Ask and Learn.
Question we are asked, which of the following system is a poset? So for something to be poset, it is a set with some relation such that it follow the three properties that we define here, the reflexive. So anything in the set must relate to itself. Anti-symmetry, it means if two things relate to each other both way, then that two things must be the same. So we cannot have two distinct elements that relate to each other both way. So it can relate in only one way. So A relate to B alone or B relate to A alone is allowed when A and B are distinct. But if it happen together like at the same time, then A and B must be the same element. Okay. And transitivity, so you are familiar with this. A relate to B, B relate to C, then A must relate to C. So in this kind of definition, the order of element in this symbol matters. Okay, depend on the relation, but usually it matters. First, real number and equality. It is clear that we have reflexive if A relate to B and B relate to A, then it is obvious because it is equality from the start that A and B is the same element in the set. So we are clear then. The last one, transitivity, also easy to see, right? This is one of the easiest one because equality has no precedent in order. It's not like the lesser than, which we're gonna see in the next one. So now, real number and lesser than. We have a problem from the start because a real number is not less than itself. Like this is strictly less than. It doesn't have equal to it. So this first condition breaks already. So it's not a poset. I should go back and say this is a poset. Okay. So this one is not a poset. And this is confusing. So I will delete it. Okay, it's just strictly less than. The next one is less than or equal to. Now we are allowed, right? Because real number is less than or equal to itself. What about this? Suppose A relate to B and at the same time B related to A. Well, it is implied that A has to equal to B. This is like one of the property of the relation less than or equal to, but you can see that it cannot be otherwise. If A is not equal to B, then it's either A strictly less than B or B strictly less than A. We cannot have both happen at the same time unless they are equal. And the third one, this should be easy to see that the symbol is transitive, right? So this is poset. Let's move on. The last one is inequality. Now it breaks the first the first one as well because real number cannot be not equal to itself, but it also breaks transitivity. If you want to think further, so A is not equal to B and B is not equal to C does not prevent A to equal to C. So it does not imply that A is different from C, right? Like, for example, 3 is not like 4, and 4 is not equal to 3. But this line of argument does not prevent 3 to equal to itself. So I should say, it does not force 3 to relate to itself, pretty much. So in fact, 3 is equal to itself. So it breaks the transitivity as well. Anyway, here you have it. You just check the 3 properties, and that is how you do it. Thank you.